And again, I hope you're enjoying this new wardrobe. My wife said, after she saw those videos, she said, John, you need to do something about your wardrobe. Every time I look at it, you got that same old dull looking jacket on and so on and so on. So today you got me in the kitty sweater. And I hope that you enjoy that kitty sweater as much as I'm enjoying how warm it is. Now, the video this morning is I'm going to revisit the concept of power, because after seeing the results on the last test, several people were just absolutely putting down answers that it didn't make any sense to me. And so let's go back and revisit how to work power problems. Now, if on this test that we had, there were two power questions, and both of them were written as word problems. And one of the things that I tried to teach earlier in the year, and I tried to get you to follow along with me, is the idea of how to work a word problem to be successful. So the first thing I would say is let's write the formulas and make sure we understand what the formulas are. Power is equal to the work divided by the time, which could be the force times the distance divided by time, because work is force times distance. Another equation that we can use is power is equal to the force times the velocity. And if you're not sure where we got that from, you don't remember, notice right here that the distance divided by the time is actually in the equation, and distance divided by time is velocity. So we could say that the power is equal to the force times the velocity. And last but not least, there's the power is equal to the change in energy over time, because we know that the equation says that the work done is equal to the change in energy. And so those are the three equations that we can use to solve the problems. Now, the second thing I want you to see is that when you read the word problem, you should be pulling the information out so that you can see what's given, so that you can solve for what's unknown. So let me look at this first problem here, and I'm going to read it and I'm going to write stuff down as we go. It says a crane lifts a load of I-beams from the ground to the 23rd floor of a high-rise building. Each of the floors is 4.5 meters tall. So right away, we've got a distance that the I-beams are being moved that is going to be 23 floors tall, and each of them is 4.5 meters, which is 103.5 meters total. Which, if you think about that, that's the length of a football field. Now, secondly, it says the I-beams have a mass of 17,550 kilograms. Mass is in kilograms. And last, it says the entire load was lifted with a velocity of 3.25 meters per second. Well, as soon as I see that, of course, the question says, what is the power? Well, the very first thing that I'm thinking about is they gave me a velocity. If they gave me a velocity, then more than likely I'm going to be using this equation right here. So now the only question I have is, well, where does the force come? Well, that should remind you of a problem. I'm not going to draw I-beams, but I'm just going to draw a box like this. And I'm going to tell you that this is 17,550 kilogram box. So we know that the weight of the box, F of G, is going to be 175,500 newtons. And there's going to be a cable attached to this, and they're going to have to pull up on the box with a force to get it to move those 23 floors. So the force that they're going to apply is equal to the weight of the box. So now, if we go back, let me change colors so that you can see this on the equation right quick. I've got a force of 175,500 newtons, and it's moving at a speed of 3.25 meters per second. So let me grab my calculator and let's push some numbers right quick. We got 175,500 times 3.25, and that comes out to a number of 570,375 watts, because the units for power is watts. And that's how we worked the first one on the test. Does everybody understand? Now, let's take a look at that second one right quick. I'm gonna have to do a little erasing here. Bear with me. But that's the way you need to work those power problems. You need to write down what information is given. You need to make sure that you see where everything's going, and that makes it a whole lot easier. Now that's a T. I kind of erased that a little bit. Let's look at the second one that they had here. A young man is pushing a 65-kilogram lawnmower. Okay? And we'll write that down. The mass of the lawnmower is 65 kilograms. You're going to see in a minute that we probably aren't going to need that mass, but let's write it down anyway. And the lawnmower is pushed back and forth across the yard to cut the grass. He pushes with a force of 42.5 newtons. Well, there's something that I need, I think. And then he says he cuts the whole yard in a time of 47 minutes. Well, there's our time. Now we got to be careful, and we'll talk about conversion here in a second. And then he talks about how going back and forth across the yard is going to be 34.5 meters every time you go across, and he had to go back and forth across the yard 31 times. So it looks to me like we need to use the equation, the first equation. And so I have the power is equal to a force times a distance divided by a time. The force that was used is 42.5 newtons. See, it doesn't really matter how much the lawnmower weighs because we're not picking it up. We're pushing it across the yard. So we're more interested in the force needed to move it rather than how much mass the lawnmower has. Secondly, we take I don't know what the answer is right now, but I'm going to put it right here like this. 34.5 times 31 is the distance. This is the force. And the whole thing is going to be divided by the time. Well, we got 47 minutes, but we also know that there are 60 seconds in each minute. And so we need to multiply that value by 60. Now, if we do that, we're going to take 42.5 times 34.5 times 31. We get a subtotal, divided by 47, divided by 60, equals. And the answer comes out to 16.12 watts. So the power that was used to move the lawnmower was 16.12. Now I'm hoping that when you watch this video and you go back and look at the questions that you had on your test, if you didn't get either or any of the power questions right, you can look at that and see exactly how we put those things together. Now, thank you for watching. I hope that you have plenty of time to prepare for your final, and have a great day.